Hello everyone, Ashok here. So welcome to the part 2, the continuation of your confusion matrix. In this video, we are going to discuss about recall and precision in more detail. All right. Okay, so this is the screen. It doesn't look nice. Let me just remove all of this. Okay, just give me a second. Let me clean this up for you. Okay. All right. So probably okay. All right. So if you did not watch the previous video, I request you to go back and watch the previous video, and then you can follow this. This is a sequel of the last video which we spoke about confusion matrix. Okay. So we have discussed about true positive, true negative, and false positive, false negative. So let me write down same numbers over here. This is actual. For when you're learning first time, it's better to have all of these labels so you're not confused with the confusion matrix. So this is true negative, and this is true positive, and this is false positive, and this is just put it below false negative. Okay, and we have discussed that recall is equal to PP by PP plus Fn, false negative. So basically, kind of this side, this actually becomes your recall. So what exactly is a recall? If you look at it, a recall is a measure of how many positives your model is able to recall from the data. So actually there are 112, if you look at here, so 6 and 106, there are 112 cancer patients because 1 belongs to cancer class. So 112 cancer records in your data set, out of which we are able to recall only 106 because my model is only able to predict 106 as a true positives, which means we are not able to diagnose these 6 cancer people as cancer. So thus they become false negative for us. So recall actually gives you a measure of how much of what percentage of the positives you are able to recall. So it's 106 divided by 106 plus 6, which is 112. If you do the math, how much you get? So 12. So 94.6. 94.6% is the recall rate, which means we are able to recall 94% of 94.6% of the positive cases or cancer cases. Okay, so in this case, in this particular example, I would like to have a recall of 100% because you cannot afford to have a single record which was positive being predicted as negative. So we cannot afford to have any false negative. The false negative has to be 0 and the recall has to be 100%. This is the desired state of this particular case because it's a clinical case and we cannot afford to have any false negative. What are false negative? Those are the cancer people predicted as non-cancer. It's very dangerous. So false negative is supposed to be 0 and recall should be 100%. So there is a matrix called classification matrix, which is from your sklearn. Let me insert few. So matrix, import classification report. Let's say print classification report and pass on my y test and y predict, and it gives you this is the class I'm interested and my recall is 95. It's rounded it up, so basically it's 94.6. It is giving us 95% as a recall. Okay, so that's recall. it's a very important measure. So in this case, I want the recall to be 100%. And the next measure is your, I'll just take in another on this slide. So let me again copy this. I haven't really prepared for, so a bit of repetition happening here. Apologies for that. So this is your true negative, true positive, and this is your false positive, this is your false negative. So the second one is precision. Precision is equal to true positive divided by true positive plus false positive. So it's a kind of, this is what we're looking at. This is your precision. Remember, recall was this, actually precision was this. So what precision actually does is, out of all the positives being predicted, how many were really positives? Recall is different. So recall is actually connecting you with the actual data set. Out of how many positives in the actual original data set you are able to predict as a positive, that was recall. So it's literally how many positives we are able to recall. Whereas precision, out of predicted positives, how precisely your prediction is, means how much positives are actually positives. So this is talking about, out of this 106, because your model is actually telling you there are 109 positives, of which 106 are actually positives and 3 are negatives. So it's called as false positives because it's falsely predicted as positives. So out of 109, how many were actually positive becomes your precision. So if you do the math, 106 by 109, so probably you get about 97%. Your precision is 97%. In this case, I am not very worried about precision because it's okay to predict people as cancer even though they are non-cancer when compared to predicting a cancer as a non-cancer. Alright, so this is also not desired, but relatively this is better because there will be further tests and probably that reveals that they don't have a cancer. That's precision. So in the case of cancer, in our case, my focus is on recall. Recall needs to be 100% with a decent precision. If you take other case, for example, I'm talking about spam filtering. Okay, so let's say you have 1,000 emails, out of which 900 are good emails or not spam. We call it as ham. Ham means good emails, and 100 are spam emails. Well, nowadays the situation is actually otherwise, but let's stick to this example. All right. So let's say you have created a model which has given you a confusion matrix, something like this. It's very important to remember which class we're going to give it as 1 and which class we're going to give it as 0. If you can imagine, my algorithm is to find spam so that we can block it. So my algorithm is designed to find the spam. So the spam will be giving as 1 and the ham, which is a good emails, will give it as 0. So I'll just put it as 0, 1, 0, 1. Well, just to remind you, 0 is actually ham and 1 is actually your spam. And you know from our previous discussion, confusion matrix, this is actual and this is predicted. I'm going to roughly put a number because I'm not going to do this. So how many 900? So 850, and let's say this is 50 and this is 10 and this is 90. Okay, so this is your predictions, and you know from our previous discussion, this 850 is actually true negative and this 90 is true positive, and your 50 is false positive and 10 is your false negative. Okay, so now you tell me which is more important for me. Is it a precision or a recall? So let's do a simple calculation. Let's first talk about recall. So recall formula is true positive divided by true positive plus false negative, isn't it? So what I'm trying to do here, even before going to that, we have to figure out which is more dangerous. Is it false negative or false positive for us? In the previous case of cancer, it was false negative because it's dangerous to predict a cancer as a non-cancer. In this case, when you say false negative, so this case is actually spam being predicted as ham. A spam or simply 1 being predicted as 0, which is ham. And false positive is the case of ham, this one, a ham being predicted as spam. Which is more dangerous for us? From a common sense or business perspective, if a spam mail lands up your inbox, that's okay because we can ignore it or we can mark it as spam. But if a ham mail goes into your spam, that's dangerous because you might miss a very important communication. So you cannot afford to lose a right email or a good email, ham, to be marked as a spam. Okay, so for me, this is dangerous. So false positive in my case is expected to be 0. So if you look at it from that perspective, false negative is recall, false positive is precision, as you can see. It's TP by TP plus FP. So in the case of spam, I am focused on precision. Precision is important for me in spam email prediction algorithm. In the case of cancer, it was actually recall which was important. So recall was important one. Okay, I hope you get the logic. So just to make it more concrete, we want to have another example. So let's say you're recruiting astronauts for a NASA mission. So you're launching a NASA mission and you're recruiting astronauts. There are two categories possible. One is qualified, and we are deploying machine learning for the pre-filtering of the candidates, for example, non-qualified. Okay. So you could imagine your confusion matrix will be something like this. Again, the same one, 0, 1, 0, 1. So again, it's important. Which one is 1, which one is 0? It's very important to remember. Our focus class, the class we are interested, is always 1. In the case of cancer, I'm trying to predict the cancer patient. So cancer is 1. In the case of spam or ham, I'm trying to predict the spam. So spam becomes 1. In the case of NASA recruitment, qualified, non-qualified. So I want to actually find qualified people. So qualified becomes 1 and non-qualified becomes 0. So the choice of this really affects, this is qualified, so non-qualified becomes 0 and qualified becomes 1. Okay, and then you can simply think about true negative, true positive, false positive, false negative, and it's pretty straightforward. So which is important, recall or precision? So again, it goes to a business case. So which is more dangerous, a qualified being predicted as non-qualified or a non-qualified being predicted as qualified? Because a qualified being predicted as non-qualified, qualified being predicted as non-qualified is your false negative, and a non-qualified being predicted as qualified is your false positive. So which one is dangerous? Well, as you might know, a qualified being predicted as non-qualified happens many places in the world. That's very common. So it's not desired, but that's not from a NASA recruiting perspective. That's okay when compared to this one, where a non-qualified being predicted as qualified and he becomes an astronaut. That's not really desired. So my pre-filtering can reject the right candidates to some extent, but you cannot really have a wrong candidate going to the next level. So this is more dangerous from my perspective. So if this is the case, then coming back to recall and precision, the recall is more focused on false negative, and your precision is more focused on false positive. So in this case, I don't want false positive to be low, so I want the false positive to be actually 0. Sorry, I don't want any false positive, means I want the false positive to be 0, minimum number of 0. So precision is what I'm looking at for this particular point. So that's all it is. So I hope these 3 examples get you a clear understanding. Whether you focus on precision or recall is purely coming from a business perspective, and precision recall itself is talking about, recall says how many positives from the data set, how much percentage of positives from the data set you are able to recall, and precision is talking about from the positives model predicted, how many were actually positives, what percentage were actually positives. This is your precision. So if you also look at your confusion, the classification report, you have F1 score. F1 score is a balanced score. It is talking about taking both precision and recall. So F1 score is a harmonic progression of classification like P and R. So it's basically 2PR by P plus R. So P is precision, R is recall. So 2PR by P plus R is harmonic mean. So high school mathematics, if you remember that, we have arithmetic mean, which is nothing but A plus B by 2, and harmonic mean is 2AB by A plus B. So this is a harmonic mean which gives a balanced view of both precision and recall. So these are very important metrics when you're dealing with a classification machine learning problem. So you're focused on accuracy is one aspect, of course, but you're more focused on recall and precision, because your business case really depends on what should be the recall and what should be the precision, which is more important. All right, hope this example is helpful. So I don't think there's no much code here, so I think video itself is good enough. I'm not going to upload this thing. Thank you very much. If you like this video, please subscribe and click the notification button. And if you have any questions, comments, please write down in the comments box. I'll be more than happy to answer. See you in the next video.